this is recording. RTI
International
Center for
Forensic
Science
presents
Just Science.
Welcome to Just Science, a podcast for forensic science professionals and anyone who is interested in learning more about how real crime laboratories work. In episode 6 of the 2019 R&D season, Just Science interviews Dr. Jorn Yu, professor at Sam Houston State University, about the chemical analysis of controlled substances using automated Headspace solid-phase microextraction. Developed in the 1990s, Headspace solid-phase microextraction isn't necessarily a novel technique. While it is a reliable method for extracting analytes, it hasn't really found a home in the forensic sciences until now. With support from an NIJ Grant, Dr. Jorn Yu is combining this tried extraction method with gas chromatography mass spectrometry. Listen in as he discusses a method for identifying controlled substances using Headspace solid-phase microextraction and GCMS in this episode of Just Science. If you are interested in emerging drug topics, please visit forensiccoe.org to learn more about the upcoming NIJ Policy and Practice Forum on July 18th and 19th in Washington, D.C. This forum will build off the momentum of the widespread stakeholder meetings convened to discuss the consequences of this national epidemic, including the impact it has on public safety, public health, and the criminal justice response. This season is funded by the National Institute of Justice's Forensic Technology Center of Excellence. Here's your host, Dr. John Morgan.
And welcome to Just Science, the podcast for forensic science professionals. I'm your host, John Morgan, with the Forensic Technology Center of Excellence, a program of the National Institute of Justice, and it's operated by RTI International. Today we have with us Dr. Jorn Yu, who presented at yesterday's NIJ Research and Development Symposium that is held each year at the American Academy of Forensic Science. We're actually at AFS here this week. It's on Wednesday in February of 2019. Dr. Yu got his PhD from Carleton University. And where is that in Canada? Is that Montreal?
Ottawa.
Ottawa.
It's the capital city of Canada.
Carleton University sounds very Canadian, indeed. Currently a professor with the Department of Forensic Science at Sam Houston State University. He is certified in comprehensive criminalistics with the American Board of Criminalistics and a fellow of the American Academy of Forensic Sciences. His research interest is in chemical analysis of trace evidence and the development of chemical intelligence for crime scene investigation. And yesterday he talked about a particular application of those ideas, which is to do Headspace solid-phase microextraction gas chromatography mass spectrometry of controlled substances. Welcome to the podcast, Dr. Yu.
Thank you for having me here.
I can call you Jorn?
Yes.
How did you first get interested in volatile organic compounds and looking at that kind of chemistry?
Well, solid-phase microextraction is not new at all. It was developed in the very early 1990s. And my PhD external reviewer, Dr. Polizio, he was one of the inventors of this technique. Mm-hmm. And he teaches at University of Waterloo, which is about 2-3 hours away from my campus. So that's where I get to know this technique, and I feel it's a great way to generate some cleaner extract that is powerful for GC-related methods.
Now, there's a lot of other ways to do vapor sampling. You know, you could use a sorbent tube. You can use other kinds of geometries that are not quite like a solid-phase microextraction. What are the advantages of SPEME, as it's often called, over other sampling methods?
This type of technique utilizes micro solid phase for extraction to couple an extraction technique with a GC. It turns out that SPEME is simpler, easier in terms of thermal desorption compared to other extraction techniques. So we can use Headspace adsorption, but to couple and dissolve those extracts to a GC system, mm-hmm. It might not as friendly as a fiber format.
Sure.
So at this time, this is just my study right now, that it has been done by many researchers coupling Headspace and SPEME with the GC-related methods. Sure. So it's just an easy transition for us in forensics to adapt what has been developed into what we need in our task.
Sure. Very nice for GC because it gives you a nice rapid desorption, right? So you have a nice starting point for anything that's coming off of the fiber.
That's correct. So it's more GC-friendly extraction, and one of the important feature about it is it can be automatic. So you don't waste extra time, labor time in extraction process. The entire extraction can be automated. That means you just need to put sample into the vial and obtain your data automatically. So by the time we have data analysis technology such as AI, then we eventually will have machine to help us interpret our data. Sure. Instead of analysts looking into data and interpret data for what we conclude from the sample.
So what kind of chemistry is in the fibers? Are those generally silicone? They're polydimethylsiloxane, or are they something else?
Those are PDMS. So these are basically a general non-polar extraction. So one of the research...
Not that much different from what would be on the inside of a GC column.
It's the same material. Typical non-polar absorption or non-polar interaction to just grab some of the organics from the sample matrix. So one of the research agenda in my research lab is to make this type of sorbent more selective by using molecular imprinting technique or other nanotechnology. So this is what I'm research into. That is to make the fiber more selective toward our target.
Okay. So you can functionalize the PDMS with molecularly imprinted polymers?
So at this time, I use general commercially available solid phase for general purpose. So if we have some task that is more specific to a low concentration of analyte that is difficult to extract, then a more selective solid phase will be helpful.
Sure. So now your NIJ award was really about using the SPME GC mass spec as a way of identifying controlled substances. Is that correct?
Right now, the grant, of course, we learned from the program director yesterday that NIJ looks for some project that can be implemented rapidly after the end of the project.
Sure.
So in terms of my prior project, that's an investigation to see how Headspace extraction can help us capture chemical signatures from the evidence. So at that time, it was marijuana.
Okay.
So that was the purpose of the project, because marijuana is a plant material. Extraction of phytocannabinoids from marijuana can be easily done, but those extracts are not very GCMS friendly.
Yeah.
So with a simple Headspace extraction, if that can be easily coupled to a GCMS, then that would be a good thing.
So in your study, did you only look at marijuana? Did you look at any other controlled substances?
It turns out that the Headspace, especially heated Headspace, heated means that during Headspace extraction, we heat up the vial.
The vial with the sample in it.
Right, with the vial with the sample in it. That will assist the extraction for our control substance as a target analyte. So for volatiles, you might not need to provide heat, but for control substance analysis or phytocannabinoids in marijuana, then without sufficient heat, we won't be able to capture phytocannabinoids from the sample Headspace. One of the purposes is that we use marijuana as one of the difficult to extract sample, and then come up with a methodology. And at this point, we feel that this heated process, combined with the Headspace SPME, can be pretty universal to other controlled substance analysis. And that's why we tried some cathinone and fentanyl, cocaine, heroines. They were all successful. So at this point, we feel it's pretty universal in terms of qualitative analysis of controlled substance from sample Headspace.
I'd have expected fentanyl to be the hardest one, that it would be the most persistent.
Fentanyl is pretty big. We place 100 nanograms, very small amount, and we still capture it from Headspace.
Sure.
With a heated approach.
With a heated approach.
And of course, we also discover there will be some decompositions due to the heat. So some of the controlled substances might decompose into other chemicals, but in fentanyl, we capture the parent
compound.
From fentanyl.
Sure. Let's going back to the marijuana. So I'm trying to speculate through all of the ins and outs of that. Marijuana likes to be fat soluble, so it must be nice and has at least one nonpolar end.
Right. That's very correct.
Yeah. And so to some extent, it might be relatively amenable to your technique. And it's kind of a moderate molecular weight. It shouldn't be, I mean, it has a reputation for being kind of sticky in a chromatograph, but it shouldn't be that difficult. But you're saying it actually, that the combination there is a little bit getting it actually off of the plant material. Is it strongly bound when it's in the plant material, or what are the difficulties there?
The difficulty is that use solvent extraction, it can be easily extracted.
Yeah.
But it's a co-extract that introduced to the system that is bad. Mm-hmm. So detection of marijuana, THC or phytocannabinoids from plant material through liquid extraction is not really a problem. The problem is co-extract come with liquid extraction that is problematic.
Because there's all sorts of
you don't want to do a lot of maintenance to your instrument after one injection or two.
Of course, some of the modern marijuana plants are so high in THC. They've all been bred to be so high in THC and low in cannabidiol and things like that.
Right.
That helps you a little bit, I suppose. It depends on the kind of plant you're working with.
That's right. And also, marijuana is inhomogeneous. That means that it's a plant material. So if you do extraction for the target from different plant structure, you might see variations.
Okay.
And also, other concern is not the detection of THC itself as a task. One of the questions is where is that marijuana coming from? Mm-hmm. So with this type of question, traditional qualitative analysis or quantitative analysis can't really answer the question. Mm-hmm. And that's why we hypothesize that from Headspace, we potentially can see more features related to either the source of marijuana or some growing conditions, like a sophisticated growing process or indoor manufacturings or other genetic modifications produce different headspace chemical signatures. And of course, there are other biological analysis can do the confirmation. But if we can use some instrument we have in the lab and then produce more meaningful data to answer the question, that would be nice.
Yeah, because there are other ways to do both presumptive and confirmatory tests for controlled substance identification. And generally speaking, a presumptive test is sufficient in many, many cases, right? So, yeah.
So we know that in SWE-drug, the Scientific Working Group on Drug, the guidelines, they suggest that a category A method combined with any other category of instrument would be sufficient.
Right.
That will bring our confidence to the level that will be sufficient for our chemical identification. And that's why GC as a category B coupled with the mass detector as a category A is a good combination. Or LC coupled with a mass detector. That will be a good piece of analytical scheme that will fulfill our work. So with that, there'll be no presumption test. You don't need to adopt multiple category B or multiple category C testing to boost your confidence level for the identification of controlled substance.
Sure. And your point also is that you're getting a much richer data set, right? You're getting more information about what's going on there than just like, is it marijuana or cocaine?
That's correct, because we know that many controlled substances could be some sort of mixture. Mm-hmm. So that kind of mixture of some other impurities or other chemicals potentially is a signature.
Sure.
So my background is a crime scene investigator with some trace evidence analysis.
Yes.
So those are value towards so-called characteristics. So with the Headspace SPME approach, we not only can detect the target control substance, we also collect some Headspace signature that associate with the evidence itself that tell us more story. So that's the data set we can get from one simple automatic methodology.
I've forgotten whether it came up in the session yesterday. I believe it might have. Certainly one of the issues in especially marijuana right now is the fact that it's becoming legalized. but there's an enormous amount of variation among the plant materials. Because it is a Schedule I, there's no FDA regulation, and so as a consumer product, it's got some red flags associated with it, and so having some methods that would be able to do some kind of screening, quality control, whatever you want to call it, would be valuable as well.
That turned out to be an interesting point because I was working for law enforcement. Usually we do our chemical analysis for prosecution purposes.
Yeah.
But at this time, it turns out that the same methodology can be used for quality control purposes for a controlled substance.
Mm-hmm.
So this is what is happening for marijuana right now. My answer is that it will do the job for quality control purposes.
You know, one of the things we talked about before we started recording was the idea that both have done a little bit of work on mycotoxins and molds and fungi and that kind of thing, which are actually relatively common in some of the commercial marijuana plants.
That's true. That's another so-called concerns in terms of residual organics and the pesticides and the mold associated with the consumer product. So Headspace, of course, will bring up some valuable information about that part.
So you've done some work in terms of the method development for the approach here, doing Headspace. Tell me a little bit in terms of the scope that you've been able to demonstrate with respect to the method. How does the method work, and where are its strengths and limitations?
Well, at this point, part of my research agenda to come up with a simple methodology. So at this point, this method has been straightforward. Mm-hmm. We have master's students in our program, but sometimes I found that undergraduate students can also do a good job in terms of complete the task.
Sure.
Because it's all automatic. So that simple is pretty straightforward. And then, of course, the challenge part would be data analysis. You can get an undergraduate to do data analysis, but you can ask the person to complete the data collection for you. Mm-hmm. So at this point, I think if there's data analysis intelligence, then the entire system will be completely human-free.
Sure.
Because the analyst will be just put the sample in the vial, and then the rest, data generation, including interpretation, will be all automatic.
There's plenty of auto-samplers for this kind of an approach out there for other applications, right?
Right. When I was a PhD student in Canada, we adopt manual operation. I did know that it's very time-consuming using SPME manually. But now there are some auto-sampler that they have been designed to do SPME work.
Sure.
So that would be very, very good in terms of sample or method development in that direction.
Now, the other thing that came up yesterday, that is that you're not just getting some really interesting target compounds, but you're also getting a lot of stuff.
That's correct.
What's the family-friendly word for it? And that, in addition to complicating your analysis, is also going to compromise both the fiber and a column, for that matter. I mean, anyone who's trying to use GC is going to have the same issue as you would have on the fiber, but the fiber is likely to be a little bit more fragile than the column.
That's right. That's the quality assurance and quality control issue, because we can always test a positive control, a negative control for the SPME fiber, make sure the SPME fiber is still functioning before we sample the real evidence. So it's part of the quality assurance or quality control procedure to make sure that fiber is still good. But from literature report, SPME fiber usually lasts several hundred rounds before you can really use it. Mm-hmm. So of course that will associate with the cost of each
Well, they're not that
analysis.
expensive, I don't believe. How expensive is it?
Each fiber at this point costs $100.
Okay.
Yeah, so still costly, but that gives you a better SPME fiber for performance.
So we've sort of outlined a few different kinds of research areas that still need to be pursued. One, of course, is trying to kind of tackle this issue of trying to extend the life of the SPME fiber. Another would be trying to have some sort of functionality on it to give you some specificity with respect to adsorption. And are you looking at whether there are ways to get around the idea of heating the sample? Because that seems like a major step if you have to take it. I'll tell you one of my perspectives on this, because one of the other things I did back in the day was looking at trying to do explosives detection using Headspace. The idea is, like, if you're trying to find landmines or whatever else it is, you know, being able to do Headspace. And for like, you have DNT coming off of TNT, and DNT is actually fairly easy relatively to find, but RDX is extraordinarily persistent and almost impossible to find in Headspace. But I would think that almost any of the drug species would be easier than even DNT, that they would be, relatively volatile.
It's much compared to explosive or other evidence,
I guess it depends
easier.
on time, the amount of time you're going to take to do the
you
sampling.
You can expose a SPB fiber onto the marijuana headspace for 24 hours.
Right.
And then you will detect THC.
Right.
That would be positive.
And that doesn't exactly lend itself to throughput in the crime laboratory.
That would be 24 hours extraction under room temperature.
Sure.
But you will see the peak definitely.
Right.
It's an equilibrium process.
Okay.
Marijuana eventually will stick onto the fiber from the headspace. So
we've been visiting Professor Arrhenius a lot today. So
it'll be
it's
24 hours. So by heating, it only takes 10 minutes.
Yeah.
So incubation for 5 minutes, expose the fiber for another 2 minutes. When you do qualitative, expose 1 minute to 2 would be sufficient.
Right.
To get the positive detection for low concentrations.
Okay. Tell me, are you continuing with the NIJ grant, or what directions are you going to go in general?
Well, at this point, the method has been developed. So the next phase will be data collection. So, of course, we will be looking for research partners that will provide us some ground truth sample, because in the university research settings, we don't really have controlled substance substance with a known source.
Sure.
So if there's any research partners that they can provide us known source of either marijuana or any controlled substance with a known source, I believe we can do a very good job in terms of drug intelligence.
Sure.
Associate a controlled substance with a different attributes, as long as we know the attributes.
Sure. Well, of course, NIDA has a program to
That's
see
true,
materials.
but at the federal level, there's a drug intelligence agency already, so we are not competing with them, but we are trying to find different kinds of tool
Okay.
that will be available, not just for expensive equipment. At a regional level, at a local level, we can do some good job in
Sure.
drug intelligence.
We get a lot of listeners to Just Science, and I'm sure that many of the people who are listening to this particular podcast especially are people who do a lot of controlled substance identification as part of their daily lives. So I encourage everyone to get in touch with Dr. Yu
Right.
and give him lots of drugs.
And I will get a lot of NIJ funds
Yeah,
to
exactly.
support our students to get the data.
Yeah, indeed. Thank you for being with us on Just Science today.
Thank you so much. My pleasure.
And thank you all for listening today, whether it be in your home or your car or your work or wherever you happen to pick up the podcast. Please make sure to tell all of your friends and colleagues to also tune in to Just Science and listen to the research community and other leaders in the forensic science community share about the cutting edge of forensic science practice in the United States and around the world. Great big thank you to the National Institute of Justice for their support for FTCOE and for researchers like Dr. Jorn Yu. Thank you so much.
Next week, Just Science interviews Dr. Adrice Makis about an image-based cloud platform for use in tagging and researching decomposition. Opinions or points of views expressed in this podcast represent a consensus of the authors and do not necessarily represent the official position or policies of its funding.